Hi there, welcome back. This is Jacob Nash Review, and this is a review of Module 7. The numbers. The numbers. That's what this is. What does that mean, in case you don't know? We're talking about statistics. Why do we need statistics? They're just dumb, aren't they? Ooh, don't say that to Vunt. That might make him a little bit mad there. Actually, no. They are needed because our guesses are often inaccurate. We need to have some way to display actual data. So how can we? Well, we already talked about scatter plots, didn't we? But we're just talking about now the different kinds of statistics. Okay, well, here's two types that we're going to talk about: descriptive and inferential. Let's talk about descriptive first. This is simply just used to organize data and characteristics by central tendencies or variation. The central tendencies, what does that mean? That's just mean, median, mode. The 3 M's, that's what the central tendencies are. Variation, that includes range and standard deviation, and we're going to talk about those later on. But there's also inferential statistics. This is used to generalize data. Do you remember what that means? That means to apply it to any case. So, all right, we can use this data for this group too. But it also looks at how likely the data was by chance or actual trend. And this is called statistical significance. And we're going to talk more about that. But guess what? Hopefully by now you know, if you hear that noise, something's important. It's things that are easy to mix up. What's easy to mix up? It's that you might think that significance means how important it is. That's not what it is. Sorry. And we're going to talk about what it is, but that's for a little bit later. Let's start out with descriptive statistics. Well, we can display this on a histogram. Maybe you know what that is. It is simply just a bar graph, but a bar graph with numbers. So here's what it looks like. Whoa. Oh, and I just got this bar graph randomly. I didn't even look at what it was about, but that looks like something related to Vunt, right? Response time. Well, actually, hours, probably not then. Whatever. Okay. The central tendencies. Hopefully you know what these are, but if it's okay if you don't. We're going to talk about it. Mean, median, and mode. Mean is the average of the data. And to find the average, you do the sum of all the numbers that there are divided by how many numbers there are. Or I say things because it could be like, well, for I don't know, that doesn't matter. But you divide the sum by the number of numbers that there are. Then the median is just a number that's in the middle of the data, but you have to put the data in order to find the median. And then the mode is the most common number that there is. Let's see which one would be impacted the most by a crazy score, meaning a score that is way out of the ordinary. It's super high, it's super low. Let's think, would that affect the mode? Not that much, really. Well, no, it wouldn't, unless it was a number that was the same as what there already was, but then it wouldn't be an extreme number, would it? So it doesn't affect the mode. Median, not that much, because that's just going to shift it one or something like that to the left or right, depending on if it was a high number or low. So the one that's impacted the most is the mean, because think about it. If you get a lot of high test scores and then you get a bad one, that's going to make your grade go down a lot, isn't it? It's not going to affect what's your most common score. Your most common score is still going to be whatever you commonly got before. It's not going to affect what score is in the middle, is it? Not that much. So mean, you need to remember that. That could be a possible thing that you would have to answer one day. And let's find the central tendencies for these numbers. And I'm going to just make this 18. But But anyways, let's look at the first numbers. So mean, let's find the mean. Now you may not have to actually do this, but I'm just doing this so that you know how to do it. So 25 plus 7 plus 41 plus 18 plus 39. How many numbers are there? There's 5. So that the mean is 26. So I'm just going to put the numbers 3 in a row on top of each other. All right, now the median, if we want to find that, we have to put these in order. Sorry to go all like math on you, but like I said, you're not going to have to do a calculation on the AP exam, but it's good to know how to. So the number in the middle, you simply just cross out each one until you get to the one that's in the middle. That's 25. Now the mode is the number that's there the most. There's no number that's there the most. They're all different, so there's no mode. Now, mean of these, I'm not going to do that again, I already said. Let's look at the median this time, because now there's an extra number. So the mean would be different, but I'm not going to do it again, because I assume that you know what I just did. Okay. So now these are in order. All right, we're going to do this again. But if there's ever 2 numbers in the middle like that, you can't cross them both out or you have nothing. So you have to take the average of those 2 numbers. 18 plus 25 divided by 2. And so the median is 21.5. It can be a decimal. Now the mode is the one that appears most. That's 18. That's pretty simple. All right. Now how do I X out of that? Okay. All right, let's continue. Skewed data. What is skewed? Skewed data it doesn't necessarily mean data that is incorrect. It means data that is misrepresented, which is common in magazines and advertisements. Here is an example. Which one of these graphs would scare you more? Let's say that there was a study about how eating chips affects life expectancy. I'm not saying this is accurate one bit, but this is just a hypothetical example. Let's say there was a magazine and you saw this in there. Which graph would scare you more? Well, let's look at this first one. This shows if you eat more chips, it just goes down a little bit. You know, I like chips. I don't really care if I don't get to live as long just by that much. But if you saw this one on the right, you'd be like, but they're trying to trick you. It's the same data. Look at the y-axis. We start at 0 here. Oops, I can't draw anymore. We start at 0 right here, and it goes all the way up to 100. But here, the graph starts at a little bit below 78, and then all the way at the top is just 78.001. It's a way smaller area that's shown for the y-axis, so that makes it look like the slope of the line is way bigger. That is skewed data. So that's something we have to be careful about. Same data, different y-axes. You might want to remember that. All right. I'm sorry if this video hasn't been as interesting as the other ones, but I just couldn't find any sort of typical things as examples, because it's just straightforward things. But we can also look at variation with descriptive statistics, and that is range and standard deviation. You may have heard of range. Range is the high number minus the low number. So whatever the highest number, let's say down here, 49, 50, 51. The highest number is 51. The lowest number is 49, so the range would be 2. Then there's standard deviation. Standard deviation is, sorry about that, I had an interruption. Standard deviation is how far the scores are from the average. So basically, look at these numbers here. Let's see, what would the averages of these be? Well, if you add all 3 of these number sets, they all equal 150. There's 3 numbers, so you divide it by 3. So both of the averages of these are 50. But that doesn't really tell us as much, except that the standard deviations are different. Look, the average is 50. 0 and 100 are a heck of a lot further from 50 than 49 and 51, right? So that means the standard deviation is different. Typically, I don't know if you've ever heard of the bell curve. That sometimes is a term described, or the normal curve, same thing, of maybe like common test scores. So usually the shape of like standardized test scores, like for example, the ACT, if you graphed it, it's like a bell shape in the graph of how far the scores are from the mean or from the average. And usually 68% falls within one standard deviation of the normal curve. That's all you need to know. You don't really need to know specifically what that means, but just know 68%. All right, now let's talk about inferential statistics. Remember, significance does not mean how important it is. It means how likely was it by chance. How likely was the data by chance and not by an actual trend? This is better for larger populations. So if there's a smaller, or if there's a larger significance, that means that it was not by chance. If there is a large statistical significance, that means, oh, it's an actual trend. It's not just some random thing. Like, oh, you know, remember, I don't know if you saw the last module video, remember Anthony Kiedis and his graph of what people thought he got more money from him not wearing a shirt at a concert. That would be a small significance, because that's by chance there, Anthony. But it's not. Actual studies that well-trusted scientific institutions do that you commonly see, that is a large significance, because what they've done, they have determined that there is a large significance and is not by chance, and therefore more accurate and can be generalized. So that's important to know. All right, well, let's just look at some 7 questions here. What is meant by significant difference? Does it mean it's an important difference? No! It means that it is likely not due to chance, but an actual trend or difference. What is the measure of how much scores vary around the mean? That, in fact, is our standard deviation. What is the mode? The number that appears the most. Simple. Okay. What is the purpose of descriptive statistics when comparing standardized test scores? Sorry, I didn't really talk about that one specifically, but here's what it is. I mean, you can just, for this question, once again, didn't create these questions, but you could just kind of say the purpose. I mean, this is kind of what your FRQs are like. You might not know exactly what purpose you would use it for test scores, but you know what descriptive statistics are, so you would want to define that, and you want to connect it. So the purpose is to organize data meaningfully by central tendency and measure of variations, which can determine useful information about the test scores for measurement and description through measures like standard deviation or mean. Which measure of central tendency is affected the most by extreme scores? Remember, that's the mean or the average, because think about it. Remember what I said? If you, let's say you got a lot of A's on your test and then you get an F, that's going to bring your score, that's going to bring your grade down a lot. Why? Because a extreme score can, and scores doesn't always mean grades, just saying. Score could mean any kind of like data. So just saying. But anyways, define descriptive and inferential statistics. Well, descriptive is organizing data strategically, meaningfully, in order to describe characteristics by central tendency or variation. Inferential is data that is more useful for a larger population, which can be used to generalize data and determine if something is true for a whole population. Also, determine if something was by chance or not. What percentage of scores fall into a normal distribution of one standard deviation of either side of the mean? That, in fact, is 68%. Oh, okay. No final slide. Sorry. There you go. Thanks for watching.